I wonder if it's still typed into my graphing calculator. It is still typed into my graphing calculator. A couple of things. Here we have the graph. And we have the parabola showing up on our window. But it's a good review to see how we could get this window to show up. First of all, if we look at the equation, can you see that when you plug in 0 for t, if I want to make just a little table of values, and this can really help in figuring out what you should set your window at, okay? Your table of values is always x and y. In this case, our x is a t, and our y is an h. So we'll plug in values for t and find out the height. Now, mental math-wise, what is the easiest value to plug in for t to figure out h? 0. If you plug in 0 for time, you know that you're going to start at 0 plus 0 plus 10. You're going to get 0, 10. Plugging in other values, can you see that 1 wouldn't be too hard to plug in? If I plugged in 1 for t, this is going to be negative 4.9 plus 50 plus 10. Mental math, what is that? Negative 4.9 plus 50 plus 10. 55.1. Yeah. Good job. So some things for setting up your window. This can help you set up your window. I'm going to show you in your graphing calculator. When I go to my window, right now, my y min and my y max. I'm starting at negative 1 for my y so that I can see my x-axis. If you don't go into your negatives, you won't be able to see your x-axis. We already know from our table of values here, we're going to have to go higher than 55. Because when we plugged in 1, we got 55. As a starting point, if I just had these two, I might go from negative 1 to 10, because it would probably be set up as 10 for my x max. I would change my y min to negative 1. My y max was probably set up as 10, but now that I know it at least has 50, I might put a number bigger than 50. I might try 70 to start. And I'll graph it and see what happens. I put 0. Go back. Come on, don't crash on me. I put 0. That's bad. Let's go. What did I say, 70? So now I'm going to graph it and see what it looks like. And I go, oh, I see part of my parabola, but it looks like I need to, oh, I see more. Nice. Like a rainbow that's blue. Okay. Those are, have you ever seen a blue rainbow? Yeah. They're always in the sky, but it's hard to see because the sky is blue too. So. Nice. Okay. So on that first attempt, just from my table of values, I got this as a graph. A couple of things about this, it doesn't go high enough. I also don't see enough to the right for it to come back down to 0. I could zoom out, but it's going to be better for you to hit your window, because zooming in and out can sometimes do way too much or not enough. So I'm going to make my x max more, maybe 15. No, you didn't do. I know, I did my scale. Man, I'm off today. 15. We'll keep our scale. This XSCL just tells you how many ticky marks you're going to make. Ticky marks, those are those little tick, 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 things. I don't know if that's the official word for it or not. The Y max was at 70. It wasn't high enough. How high do we want to try? 150, because that's what we had before. I'm going to make my Y scale, because if it's at 150, it's going to go and just basically fill that thing up. If I make my y scale go by tens, that might be a nicer scale for those ticky marks. And when we graph it, 150 was a good choice. And that's the graph that we had before. Everything's slow today. Did it work? Okay. Let's bring this graph, drag it over here. There we go. So there's our graph. You have to just draw a sketch of it. What we'll put on this sketch is that we went up to 150. This is our height. We'll label this as our time. That's t. This was h. We went up to 15. We went by tens here. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. That way we have an idea of the scale that we have from our graphing calculator. And since we did a table of values here, we can label those points. We know that when the time was 0, the height was 10. We know that when the time was 1, the height was 55.1. We did that by taking the equation and actually plugging in 0 for t. And then we got 0 plus 0 plus 10. That was pretty easy. And 1 for t would be negative 4.9 plus 50 times 1 is 50 plus 10. And we did that for mental math. Now the nice thing, now I showed you those two. Well, 1 squared is.
Yeah, but we were doing negative 4.9.
But then a negative 4.9 t squared, so order of operations do the t squared first.
Oh, I see. Wait.
And then times by negative 4.9. Now the nice thing about your graphing calculator is it does table of values too, especially on one like this. Can you see plugging in 2 would not be such a fun mental math exercise? But your graphing calculator, above the graph button, it says table. If you go second, table, 0, 10, 1, 55.1, 2, 90.4, 3, 115.9. That is very amazing. Yes? We just guessed, we just randomly guessed. Now, the table of values can also be very, very helpful for figuring out how you should set your window. Because can you see that the biggest it ever gets is at 5? At 137.5? Because it's like a rainbow, like that blue rainbow that you see every day.
I see rainbows every day.
Okay? Can you see from here that 150 would be a good choice? And if we went down, it goes into the negatives after 10. So we chose 15. Now when we look at our graph, we can see that on our graph. That's where it goes into the negatives. We can see the 137 as a high point as well. So our table of values is very helpful. Does anybody's table of values not start at 0? What number does yours start at? 0.71828? Oh, yours has got really nasty looking numbers. So if your table is not at the right values, above this window button, it says table set. If you go to table set, mine is set to start at 0 and go up by 1s. Yours is set to start at something else. Okay? And there's always someone in class who says, I wonder how far I can go down in my table before class ends. And they get to like 2,000 and they're like, woo. And the next day we do a table question, they're like, I'm at 2,000. They try to go up 2,000 to get back. This is way quicker. Table starts 0, perfect. Yours is good. And then you can get out of something by going second quit, and now when you go back to your table, it's starting at 0, which is nice. So second window gets you back to your table setup. Well, then let's set it at started at 0. Not negative.
0?
No, just 0.
Negative 0?
Delete. And then go up by 1. Now when you go to second table, it starts at 0.
Now how do I set the
You need to make sure that you have your equation written in y equals. Yeah. Yeah. Okay. So that also can really help you set up your window, because that tells us we went up to 137.5. 150 or 140 makes a very good choice for setting up. We know that it's switched between 10 and 11 to negative, so you might have only chosen 12 instead of 15 for your window. We've got it graphed. We've got a nice graph from our graphing calculator. Our graphing calculator can find all of these important information: intercepts, x-intercepts, y-intercept, the coordinates of the vertex, that's going to be this red point right here, the domain, and the range. Okay? So let's go through each of those things and how to get them with our graphing calculator. First of all, we'll start with the y-intercept. The y-intercept we already know is 10. That was easy because you just have to plug in. And this should be something you never have to use your calculator for, because plugging in x equals 0, in this case it's going to be t equals 0, because the equation with the t, that's going to be easy.
So the vertex is the peak of the
The vertex is the peak of
parabola?
the parabola.
Yeah.
Unless the parabola is going up, then it's the bottom.
What's the bottom then? Because it does go around the circle.
No, it doesn't. This goes down forever and just keeps going. Yeah, it's just a U shape that keeps on going. Now, this one you should be able to do just by plugging it in. However, if you have trouble with that, you can also do it on your graphing calculator by going second, calculate, and number 1 is a value. What that value does is it says plug in an x value. And we want to plug in 0 for x and see what our calculator tells us, and it tells us that y is 10. It does it for us. Yeah.
For mine, it just keeps saying 35.9.
Because you haven't typed in this equation yet.
Yeah, I did.
And you have to put in x's instead of t's. Here's the x's. So you're going to have to go negative 4.9 x squared plus 50x plus 10. Yeah. Okay, so that is our x-intercept. Our y-intercept. To find our x-intercepts. Sure, there's more. We have to find all the intercepts. We have to find the coordinates of the vertex, the domain, and the range. We're on B. To find your x-intercepts, that is when y is equal to 0. Solving when y equals to 0 by hand, you'd have to use the quadratic formula, because this doesn't factor nice. Okay? On your graphing calculator, you can find it in one of two ways. I'll show you two different methods to do it. First one is the most common, because we want to find, and there's two of them, we want to find second calculate. What is another name for x-intercept? There's 3 of them that we wrote down the other day. X-intercept, 0, and the third one? X-intercepts, zeros. Starts with R, rhymes with toots. Roots, good. On here, it's listed as 0. So if we push enter on 0, it'll say, let's find one. First thing you have to do is to go to the left of it. Can you see that I've got my cursor really close to it right there? It's basically on the 0. If I want to go to the left of it, I'll hit my arrow key a couple more times to the left and push enter. It'll show an arrow, and it'll say, is that to the left of it? That's good. The new calculator has a nice little dotted line. The old one just has the arrow. Yes. I am recording this.
Second function calculate what
Is my calculator supposed
what
to
next second function calculate then what behind it?
And then a 0, number 2.
Just 0?
No, number 2
Oh, okay.
says 0. Now I need to go to the right of it.
Mine won't show the arrow.
Maybe you went off the screen even. You went so far to the left.
Yeah, I did something too.
Is my cursor to the right of my X-intercept now? See where the cursor is? You see that it's to the right of the X-intercept? So I am now on the right side. I push enter again. It will find if there's an X-intercept between those two lines, and yours might just have the 2 arrows at the top. If there is an X-intercept between those two, it will find it. For whatever reason, the calculator always says, do you want to guess? I'm guessing it's right there. And then it tells you exactly what the value is. When y is 0, one X-intercept is negative 1.96. For our equation, zero, was it negative? Oh man, forgot the number already. Negative 0.196.
Does it have to be to the right and left the same amount?
Not the same amount, just has to be to the left and to the right. All right, I'll come and help some people. Okay, back to our graphing calculator, let's find the second one. You can also, when doing left and right, so I'm going to find the 0. Now I want to find this one. We already know from our table of values, when we looked at our table of values, that it was between 10 and 11. We could also figure that out just by counting our ticky marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's between 10 and 11. You can use the arrow key to go a whole bunch of times to get to the left of it. A shorter way to get to a point that we want, say I want to use 8 as my left, I can just type in 8 and it'll automatically put the arrow at 8. That's even quicker than using your arrow over bars to go to the left and the right. What would be a value to the right of this? Maybe 12, 13, doesn't matter as long as it's to the right. So I'm going to use 12 as my right one. It does my 2 arrows. Is my X-intercept between those 2 arrows? Otherwise, your calculator will say error. Is there an X-intercept between those 2 lines? Yes, there is. So now when I say enter on the guess, it tells me what it is exactly, 10.4. So the other one is when t is equal to 10.4. Now, considering this being a real-life example of something being shot into the air, does it make sense that it was on the ground 0.19 seconds before? Not really. Logically, you can't go back in time. So this one doesn't actually make sense given the context, but it does make sense that it flies through the air and hits the ground at 10.4 seconds. On your calculator to find the vertex. We go to our calculator. We go back to the calculation button. Which one of these do you think is going to help you find the vertex? Because it doesn't say vertex. Maximum. For this time, the vertex is the maximum. So we're going to go down to number 4. Push enter. Same way we got there in the other one. Second, calculate. It's asking for the left side again. Remember we said our maximum was around 5 when we looked at our table of values? So if we go to the left, we could go to 3. Is that arrow to the left of my maximum? Yes, it is. If I go to, say, 7 on the right, is my maximum between those 2 arrows? Yes, it is. Push enter again, and it will tell us exactly where the vertex is. So it wasn't at 5, It's at 5.1. 5.1, comma, 137.55. The 5.5 is the x, the time, and the 137.55 would be the height. So that means after 5.1 seconds, the projectile is 137.55 meters above the ground. Now, if we were just finding last things, I'm going to solve the domain and range if we were just looking at a regular equation, and we're also going to solve the domain and range in context. One of the things we learned about parabolas is that the domain is everything. Since we're using t instead of x, in a regular equation we would say the domain is everything. And in a regular equation, if we were just looking at this parabola and needed to say the range, we know that it goes down forever, but it hits a maximum at 137.55. So our y values, in this case it's h, our h values have to be less than or equal to 137.55. That would be our range. In the context of this question, though, this projectile can't go down forever. It doesn't make sense to have this equation go back in time. So what makes sense as far as this equation goes is starting from time equals 0 and going until it hits the ground, and when it hits the ground here at 10.4. In the context of the question, this is when the domain makes sense. After 10.4, that projectile is going into the ground and burrowing. That might not make sense. The range, given this context, is it hits the ground, so the lowest it ever goes as a height is 0, and it goes up to 137.55. So sometimes we're finding domain and range just of the parabola, just of the equation. That would be regular. That's what we have here on the left. But sometimes we have a context of a question. Then we have to think within the context of a question what makes sense. It only makes sense from when it's shot starting at time equals 0 until it hits the ground, because then it would probably bounce a little bit. And if that's what we're considering, then it only makes sense from a height of 0 when it hits the ground up to the maximum, which was its vertex, which is 137.55. Question you can do for this one is number 10. Just number 10.